Hi, it's Anonymous, and today we're going to talk about thermodynamics. This may seem intimidating at first, however, we can really look at the word and break apart to figure out what thermodynamics is. So, thermo meaning heat, and dynamics meaning motion. Therefore, all thermodynamics really is the study of heat as it moves. It's essentially the motion of heat. So, say we have a system, or yeah, say we have water that's boiling off. Now, this water is boiling off because it's being heated up by a flame. Okay, so it's interesting to note that I said we have a system. In reality, a system is defined by the part of the universe that we're studying. In thermodynamics, we call this a boundary layer. So we could define the boundary layer to simply be the candle. Now, the surroundings are defined as the outside part of the system. So, this is a type of this is a type of open system because mass may enter and exit. You see, this system is open because we have the byproducts of any combustion reaction, which are at least CO2 and water, that are leaving the system. In addition, due to convection, we have O2 entering the system. So this type of system is called an open system because mass may enter and exit. Remember, oxygen, CO2, and water all have a mass. In contrast, a closed system would be in the case where no mass may enter or exit. However, energy can enter or exit. Now, in thermodynamics, there's this thing called the assumption of continuum. And all that is when all molecules behave the same from a macroscopic point of view. So, say you have some wooden log, and you've cut it up, made it into a desk. Well, regardless of how far you view into the wooden log, in thermodynamics, you'll still see wood, and it'll look the same as if you look at it from a broader point of view. Essentially, all molecules behave the same in thermodynamics. We're looking at this from a macroscopic point of view. Now, in thermodynamics, we also have this item called a state. All state is a collection of properties. And all a property is a characteristic of the environment, such as mass, temperature, pressure. And when we move from one state to another, this is called a process. For example, we say that a process has occurred when I put my hand on this pin. A process is occurring at the moment because the temperature of the pen is changing and the temperature of my hand is changing as well. So essentially, we've just moved from one state to another. We've moved from one collection of properties to another. So that's all a process is, just a change in state. Now, after a while, if I leave my hand on this pen for a certain amount of time, who knows, maybe 10, 20 minutes, the properties of the system will start to not change very much. In fact, over a long period of time, they will be unchanging. This is because if we look at the temperature of the pen and the temperature of my hand, they'll reach a sort of equilibrium. So at this point, we will have reached a steady state. All a steady state is when the properties of the system are not changing in time. In fact, there's this thing called thermodynamic equilibrium, in which there's no flow of matter and energy or no phase changes. So in this case, after a long period of time, once you reach steady state, we'll have achieved a thermodynamic equilibrium. There's something else called quasi-equilibrium, which is an infinitesimal small change in equilibrium, but we'll speak of that later. Now, each of these properties are categorized differently. We have two types of properties: intensive as well as extensive properties. Now, what makes an intensive property unique from an extensive property is an intensive property is independent of the amount of matter. For example, boiling point, temperature, hardness. Pressure. Regardless of how much water we have in this container, the boiling point of water will not change. Think about that. The boiling point of water will always be 100 degrees Celsius or 212 degrees Fahrenheit. In addition, temperature is also independent of the amount of matter. Simply by having two people hold hands of the same body temperature, 98.6, their body temperature will not suddenly double. Same for hardness. If we look at a stone, in this case shaped in the box, and a stone of double the mass, given that each stone is of the same material, the hardness will not change. This is also true for pressure. You see, if we have a helium balloon filled with helium atoms, all colliding on the sides of the balloon, and we say the pressure in this balloon is 20 psi. Regardless of where you look in the balloon, the pressure will always be 20 psi. In fact, if you cut the balloon in half, and seal both halves, the pressure of each half would still be 20 psi. For this reason, pressure is an intensive property. It's independent of the amount of mass in the system. Now, if we look at extensive properties, some of these are a bit more concrete. For example, we have mass. Mass is dependent on the amount of matter. If we have twice the matter, we have twice the mass. Therefore, mass is an extensive property. Another extensive property is volume. If you increase the amount of mass in an area, given that the density is, of course, the same, the volume will increase. Therefore, the volume is dependent upon the amount of matter. The same is true for size as well as weight. So that's an overview of thermodynamics. And as you can see, to start off, it's not that bad. Essentially, thermodynamics is the study of the motion of heat. Thanks for watching. It's been Anonymous.